Okay, for this section, 10.5, it's implicit differentiation. And I want you to we'll probably have to watch some problems to really understand this idea, but it is a lot of algebra, so make sure you watch every problem. But if you think about something that's explicit, like it'll be directly stated, it's explicit. If it's um, implicit or like it's not quite directly implied, it's implied like mathematically y as a function of x, it's written a little bit different. Um, so a direct comparison, they try to write it here. They're basically saying when we look at like a function like this is directly stated, and then they say this one or explicit, this one's implicit. So these are stating the same thing, but written different. So the whole idea of today really is going to be to write it a little bit different, to do the derivative without being necessarily solved for y. So a little bit different way to solve these. We'll also have some values that we will put into the function. So let's look at a couple of these, and that will kind of help us with um, maybe like what it exactly means. But I would definitely just read the idea of it on that front page. But if we look at this one and we solve the equation for y, then find the derivative, this is in your wheelhouse. It's not too bad. So I need to solve for y, right? So I'm going to start with moving over the 7x squared and the 21, right? So right now I have 7x squared plus 5y minus 21 equals 0. I'm going to minus the 7x squared and add the 21 over to the other side. Okay, so that those two go away. Now I'm at 5y equals the 0 minus something isn't going to really matter. So I have a negative 7x squared plus 21. Now I have divide by 5. When you divide by 5, I like you to think about that I divide each one separately in case you can reduce any of the fractions. I can't really reduce 7/5 or 21/5, but still like this habit. So we're done. And we we don't want to use a quotient rule if we can just divide it under each portion. So this will equal, just, well, y equals, I guess, just the negative 7x squared over 5 plus the 21 over 5. Now, if we wanted, this is explicit, just so we know too. And this is the old way. It works easy for this problem. It doesn't work easy for others. Okay, so we're done. We have this explicit problem. We could then take the derivative if we wanted. So I'm going to just do that over here. But the derivative of this function could be, all right, the 2 comes down times by the negative 7. So I see negative 14 over 5 still. And now it's an x. And the 21 fifths goes away. The implicit method, the idea of implicit, is when I see a y, I actually write the derivative of it, like a y with a prime symbol, every time I do the derivative. So I look straight at this and I take derivative, derivative, derivative. But if I do a derivative of the y, the 5y part, I literally add in y prime because I don't know I don't know what the derivative of that is, and it's not in terms of x. So here's what I mean by that. You're going to write y prime for the derivative of any y. Could have more than one y. So for this one, if I take the derivative of the 7x squared, I'm going to get 14x. When I take the derivative of the 5y, you would just have 5, right? So I'm going to add plus, you just have the 5. But anytime you take a derivative where there's a y, you're going to add y prime because you don't know what the derivative of the y prime is. Seems weird, but that's what we do. And then we have the 21, which goes to 0. So it looks like this for taking the derivative. Now, then I can solve for y prime. Sometimes you have to solve for y prime, sometimes it doesn't make you. But if we solve for that, we would minus the 14x over. So I'm going to have 5y prime equals a negative 14x. And then I need to divide by 5. And our y prime is equal to negative 14x over 5. So these are the same answers, just done a little bit different. Okay. So old way, new way. So when we look at use implicit differentiation for 2, we use implicit differentiation to find the first derivative and evaluate it at this given point for x and y. So when I look at this and it gives me a value, basically you will find the derivative like this that with y prime, and then you plug in the 3 and the negative 2 into any x or y, basically. Some of the problems are so basic, they don't have a y for you to plug anything into. That's this one, and your homework starts that way. It's almost more confusing if you don't have the y, but if you don't have a y, you don't have anything to plug the negative 2 into. So for this one, we want to start with taking the derivative. And we're going to do that of exactly what we see implicitly. So the derivative of 3y is just 3, but I took a derivative of a y, so I add y prime. Okay, so the answer is just 3, but I have to add a y prime because I don't know what that is there. And then this with the 6x to the third, 3 times the, well, it's a negative 6, but is going to give us what? Negative 18. And then drop 1, so I get squared, and then the 8 goes away, so we have just this equals 0. So 8 goes to 0, and the 0 stays 0. So here we are. This is our implicit, and then what we're going to do for this one is we can solve for y prime. So we can solve for y prime. That means we're going to add that 18x squared over and divide by 3, which would be the same as 6x squared. Okay. And then we put in the values we're given. We don't actually have a y on this one. We only have an x. So when we use these numbers here, x is equal to 3, y is equal to negative 2, but there is no y. We have a y prime, not the same. Okay. So we would literally have y prime is equal to 6 times 3 squared, which is 54. So 54 is your final answer for this one, and we did it implicitly. Okay, so this one is kind of making us look at just doing the implicit differentiation of one term. So look at A, it's x times y squared. This is a function times a function. So we have to use the product rule. So the first term is an x, and the second one is y squared. So the derivative of this first one is just 1 because the derivative of x is 1. What is the derivative of 2y? So this is going to be new. The derivative of the 2y, we know, or sorry, y squared is 2y. I was already saying the answer. So we would bring the 2 down. We know this would be 2y, but anytime I take the derivative of a y, I add a y prime, or the derivative. Okay, so in this one, when we go to do this one, we know we times across, right? So we would have x times the 2y prime. It's a prime plus, because it's product rule. Y squared times 1, which is just y squared, equals 0. So that's our function. That's all this one's asking for. If we had to solve for y, we could do it, or y prime, excuse me. You could take these terms, right? Minus this one over, divide by those terms. If it asked for us to write it in the form y prime equals. Okay, B. How am I going to do B? This one's kind of like a chain rule because you have a y up there. So we know the derivative of an e stays the same. So the derivative of negative e to the y is negative e to the y. And then you times it by the derivative of the inside, the derivative of that exponent. Well, the derivative of y is y prime. So chain rule. Anytime you have something that's not just x in the exponent on an e, you have to times by the derivative of the inside. Okay, C is, well, you have times, I did it differently over here. You got your first term is going to be x. Your second term is natural log of y. I don't think I don't like how I showed it on my little notes. I'm just going to do it this way. So then we have the derivative of that is going to be 1 for derivative of x. But the derivative of this natural log of y, well, we think about it, it's 1 over whatever's in that spot, which is a y instead of an x. But so it's going to be 1 over y, but then you have to times it by the y prime because you took the derivative of the y prime. Okay, so then let's put this all together. We would have x times 1 over y times the y prime, right? Times those two. And then 1 plus 1 times natural log of y. Okay. So for this one, hang on, I'm going to pause just for a quick second. Okay, so we're done pretty much with this because we can't simplify much. Equals a 0. I didn't have the equals 0, but that's pretty much all we can do. We can write it as like the x over y. But yeah, that was pretty much all we can do on that one. Okay, so for D, we have a chain rule for sure, right? So we know we're going to bring that 5 down. We could use the u if you want me to, but we bring that 5 down times 2x minus 3y all stays the same to the 4th power. So this is like do the big outside, right? But then you have to times it by the derivative of that inside. Well, the derivative of 2x is 2. The derivative of the 5 times the 3, not 5 times 3, the 1 times the 3, or the derivative of 3y is just 3. But when you take the derivative of the y, you add the y prime. Now, we didn't take a derivative of a y in here. They took the derivative of the outside. Okay, so then we have this equals 0. Okay, now these are just working on chain rule, product rule. Should have done a quotient rule too, but they didn't. And looking at E in the implicit kind of way. So the problems, that should help you with the problems that we'll do in the next part. So 4, excuse me, is our next problem. And this one has numbers 1 and 4, and we need to take the derivative implicitly. So when we look at 5xy to the second, that is 2 terms or product rule, right? So just for this term, I need to look at it as 5x for the first thing, and the second one is y squared. So the derivative of the first one is just 5. The derivative of the second one is 2y, but you have to add a y prime. So I took the derivative of a y, add the y prime. Okay, so that all, when I go to the derivative, replaces just the first term. So times them by each other. So 5x times 2y prime plus 5 times the y squared. That is all the first term. Then the second term is 8y, so the derivative is just 8, but I took the derivative of a y, so we'll add in that implicit of the 8 prime or y prime by the 8. And then the next one just has an x, so 2 times 3 is negative 6x equals 0. So if we want to solve for y prime, we have a y prime here, we have a y prime here. So I'm going to need to factor the y prime out of the two terms that have the y prime, and then the terms that don't, I'm not going to factor it out of. So that's tricky. So I'm going to write y prime, and I'm going to factor it out of this very first term here. So basically this goes here and everything else is still there. So, and we could times 5 times 2 is 10 x, y. You can times those together. And now the y prime has come out front. And then the other term that has the y prime is this one. So I'm going to write it with just the 8 and the y prime has gone out front. So we've taken care of, oops, this term. I didn't mean for it to write, but it's okay. And this term, those are both written first term, and we took the y prime out. So we still have this 5y squared and the 6x equals 0. I'm going to add another page on here real quick because I don't think I'm going to have room to finish. There we go. And then from there, because I have that big Pearson thing in my way. So then from here, if I want to solve for y prime, I could minus this term over, add this term over, and then I can divide by this. So that's what I'm going to do next. I'll start with just moving the two terms at the end here. So we have this, and now it equals a negative 5y squared minus, plus 6x on the other side. So minus the 5y squared over, added the 6x. Now I can divide both sides by this 10xy plus 8, 10xy plus 8, and we would have y prime is equal to this whole thing over 10xy plus 8. Okay, and I know this seems crazy, but when we do related rates in the next section, then we'll see how it relates to business. But for now, it's more like learn the technique for this section. Okay, so y prime equals this. Were we given numbers for y prime and or x and y? Yes. So then we can find the an actual value number, right? So we're going to put in for y 4 and 1 for x. So I'd have negative 5 times 4 squared plus 6 times 1 all over 10 times 1 times 4 plus 8. If I did it right on my calculator earlier today, then I got negative 74 over 48. So hopefully that is the correct answer on that one. Negative 74. This one, is it the same problem? This one says, oh yeah, that's the same answer. They just reduced it. Just kidding. Negative 35 over 24. They just reduced the fraction. I was like, wait, what did they do different? Perfect. This is what we're headed to. Something harder that has more than one y prime. It has x's and it has y's where I can put values in for those. Okay, so let's look at problem 5. Okay, so we have a couple more. 5 has got logs. We definitely want to do this one. So 5, we look at that 7 natural log of y. The derivative of that would be the 7 stays on the top, right? And the y goes to the bottom because it's the natural log is 1 over x or 1 over y. And then we'll have to times that by the y prime because we took the derivative of a y, or that chain rule derivative of the inside is y prime. Okay, equals the derivative of e to the x is e to the x. Derivative of the 4x squared would be 8x. And then another one with a y, so this would become negative 6y times, again, a y prime. Okay, so if we want to solve for y prime, we would need to move this term maybe over here so that the two y prime terms are on the left. So that would make 7 over y times y prime. That's a plus now when it moves over y prime equals the e to the x plus 8x. Okay, so we're here. Now I'm going to factor out a y prime. That's going to leave 7 over y plus 6y equals e to the x plus 8x. So we'll divide over that entire parenthesis, and that's going to give us our y prime. Okay, so good, we're there. Now put in your values. So e to the 0 plus 8 times 0 over 7 over 3 plus 6 times 3. Well, the top is 1 plus 0. So the top is just 1 because e to the 0 is 1. So 1 plus 0 is 1. And then on the bottom, I have 7/3 plus 18. Can I cheat? I got 61/3. 61/3. Flip that over, multiply by the 1, and I get 3 over 61. Division, flip and multiply, right? Put it in your calculator if you need to. So that's the final answer using implicit differentiation at an exact point. Okay. This one is terrible because it's just a long problem. We need to use the product rule. So two product rules make this one a little bit long, okay? So that first term, our first thing is x squared. The derivative of that is going to be 2x. Okay? The second term is y to the third. That's just going to be, what, 3y squared, but I took the derivative of a y, so I'm going to do y prime. Okay, the next term, maybe I'll label these just so that we know what terms these were. The next term is xy squared, so the first one is just x. Its derivative is just 1. The second one is y squared, so its derivative is 2y prime. Yuck. So we'll put that all together, times, right? So this first one will be x squared times 3y squared y prime, and then plus 2x times, you could use parentheses, time symbol, don't really care. Y to the third, you could combine them together already. Either way. So that is just the first term. Oh goodness, I don't think I'm going to be able to fit this all on here. Um, I was just maybe going to need to write a little smaller, like maybe I'll move this one in at least. And this would be y to the third. I was like, oh my goodness, I need to squish this stuff in. Okay, plus over here, we're going to have the x times the 2y prime, however you want to times those two together, plus 1 times y squared is just y squared. Again, you're just cross timesing, right? First original times derivative of the second, times second's original times derivative of the first. Now I can get to this third term, which is going to be what, just -6 and then y prime for the derivative. Derivative of -6y is just -6, keep the y prime. Okay, plus 4 over natural log of x. The 4 is going to stay over the x, and the 6 becomes 0. Phew, I barely squished it in. Okay, so each term that has y prime, y prime, y prime, y prime, we need to take that y prime out and write what's left. So this first one is going to be a 3, an x squared, a y squared in that first term, right? And then plus, we'll have the second one right here, which is just 2xy. plus this last one here. Oop, it's a minus. Um, it's going to be minus 6, taking out that y. So there is those three terms that had the y prime. We took the out of each of those, and then what we have left is the other terms here. So the 2xy to the third and the y squared and the y, or the 4 over x. Ooh. So take those terms, right? Move them all over slowly and then divide by this. So it's gonna look like this. Okay, opposite sign. So negative 2x y to the third minus y squared minus 4 over x. So opposite sign all the way across, all divided by the exact what we see, 3x squared y squared plus 2xy minus 6. Oh, ain't that pretty? Then we put in the 2 and the negative 2 and the 3 that we were given, and I got 101 over 90 is what I got on that one. 101 over 90. So hopefully I put that in correctly. Calculator game at that point. It's just a pain in the butt, right? Putting all those numbers in. Now you know why in algebra we made you practice putting in numbers into a big ugly thing. So you could do it here. Okay. I think this is pretty much, let's do one more because it has a square root. Evaluated at the given point. Yeah, this one's probably 8 is fine, but like 7, really, we need to probably do something with a radical or that square root. So we're going to rewrite this term, right, to be 2y to the third minus 16 to the 1/2 power. That term needs to be that, right? And this is a chain rule because it has stuff inside to an outside power. So when I do the derivative of it, it's going to come down as the 1/2. Everything stays the exact same. 1/2 minus 1 is negative 1/2. And then you have to times it by the derivative of the inside. Chain rule. Times by the derivative of the inside. So the derivative of 2y to the third is going to be 6y squared, but then it'll keep a y prime, derivative of the inside, and then minus 16. The 16 goes to 0. So that's it. That's all just the derivative of that first section. Then we have the 5x squared. So 2 times 5 is 10x. 13 goes to 0. So remembering that chain rule with the square root. Now, y prime is only here. So I'm going to minus the 10x over, and then I will have to divide by all of this part, right? Okay. So I'm going to minus the 10x over. So right now I'm going to have, well, actually I have to divide by all. I forgot this part. So I have y prime equals the negative 10x that I moved over. And then I'm going to divide it by everything. 1/2 2y to the third minus 16 to the negative 1/2 times 6y squared. Now, I know I have a negative 1/2 exponent and I have that in the denominator. I could move that back up to the numerator, but it doesn't really matter. When I put in the 3 and 2, I should still get the same answer. Okay, so if I do, I'm going to do this one all the way out. So the top is negative 10. The top is negative 10 times, what's our x value? 3. So I got negative 30. And then on the bottom, I'm going to take 0.5 times 2 times 2 to the third. And then 2, oops, yeah. And then minus 16. All of that to the power of negative 1/2. Use the negative by the enter for an exponent that's negative, and then times that by 6 times 2 squared. Oh, that's ugly. Go to, where did I have an error? times by 6 times, it doesn't like how I typed it in. I'm not sure why. I'm gonna delete part of mine off. It still says domain -1. Oh, I'm getting, am I getting a negative under the radical? Hold on, 2 times y is 2, oops, clear, just got good. 2 times 2 to the third minus 16. Oh, maybe I did that in the first one. Minus 16. Okay, 0. I just had to go back to, I must have typed something in wrong. This is 0. 0 to any power is still 0. 0 times that 0. So 0 times this is 0. That's why it's giving me an error, is because of the way I typed it in. Ooh, I'm getting undefined, which is not the answer. So maybe I do have to move this up. The answer is going to be 0. Okay, so what I mean by that is this term probably needs to come up. So let's rewrite this. So it's going to be the 2y to the third minus 16 to the 1/2 power on the top. And then in the bottom, we still have the 1/2, which is fine, and the 6y squared. Let's try it this way. Now we're going to put in the 3 and the 2. So negative 10 times 3, put the parenthesis 2 times 2 to the third minus 16. Sometimes I accidentally leave things in in the wrong form, but now I get 0 on the top instead of 0 in the denominator, and the bottom is going to be like 12, right? Because 1/2 times 6 is 3. 3 times y squared is 4. So 3 times 4 is 12. So really this is 0. So maybe I have to be a little bit careful with where that fraction was to the 1/2 power, because it ended up making a 0 in the denominator. So just double check. You can still get undefined and get a 0 in the denominator. So that is a possible answer. So just double check that you can't rewrite it and get a little bit different answer. So that one ends up just being 0. Okay, I'm going to stop the video there. Basically, this whole section is really about solving for y prime and putting in numbers if you're given them. All right, let me know if you have questions.